We are going to continue talking about rational numbers. So in the last video we talked about how we could express integers and fractions as rational numbers, but some decimals are also rational numbers. So we need to be able to show that they can be written in m over n form, or written as a fraction with an integer on top and an integer in the denominator. So let's talk about how we can show this. So if I was given the decimal 0.4, and I need to write this in m over n form. So I know that the 4 is in the tens place, and I have 10 as the denominator, so I can use 10 as the denominator. So I have 4 tenths. Now remember, since the 4 is in the tens place, I can write it as 4 tenths. And 4 tenths can be reduced to 2/5. And I figured that out because I saw that I could divide both the 4 by 2 and the 10 by 2. So 4 divided by 2 gives me 2, and 10 divided by 2 gives me 5. So let's try something a little harder. So if I have a negative 0.186 thousandths, I see that I have a number in my thousandths place, so I can use thousandths as my denominator. And all I have to do is take this number and write it as my numerator. So I have 186 thousandths. And I can't forget my negative sign. Now all I have to do is simplify that. So I see that they are both, again, they're both divisible by 2, which means they can both be evenly divided by the number 2. So a negative 186 divided by 2 gives me a negative 93. And if I take 1,000 and I divide it by 2, I will get 500. All right, let's try another. So let's say instead of just less than 1 or greater than a negative 1, let's try 30.5. So I have an integer here of 30, so I can just rewrite that. So that's going to equal an integer of 30. And I see that I have my 5, and that's in my tenths place. So I can use 10 as my denominator, and 5 will be in my numerator. Now I have to write that as an improper fraction because this still isn't in m over n form. So I have a mixed number and I need to make it into an improper fraction. Now remember, I have this integer here, which means that to make each of those whole numbers, and if I were to look at them in size 10, I have to think how many pieces would I need. So I have to take 30 and I have to multiply it by 10 to figure out how many pieces it took to make those 30 whole numbers. So 30 times 10 over 10, and then I'm going to add on my 5 tenths. So 30 times 10 equals 300, and I'm going to add my 5 tenths. So this gives me 305 over 10. Now I'm going to have to reduce that, and they are both divisible by 5. So that would give me 10 divided by 5 is 2, and 305 with a little calculation will give me 61. Now, I could have gone by that a different way. So, let's try it in a different way. I'm going to get rid of this. Now, what if I took a look at that 5/10 that I have up there? And I know 5/10, that's 1/2. So I could rewrite it up here as 30 and 1/2. I still am going to have to make it into an improper fraction, but I have smaller numbers to work with. So I'm still going to see how many whole numbers, or how many pieces of size 2 I had to get 30 wholes. So I still have to do 30 times 2 over 2, and I will have to add that extra 1/2 in. So 30 times 2 is 60. 60 halves plus 1/2 equals 61 halves. Just like many things in math, there are many different ways to go about solving the same problem. Let's try one. So let's say I have a negative 1.48. So again, I see I have an integer here, so I'm going to rewrite my integer. So I have a negative 1, and then I'm going to take this 48 hundredths, because my 8's in the hundredths place, so I can use 100 as my denominator, and I have 48 in my numerator. Sorry, it looks a little bit like 9. Let me fix that for you. Okay. There we go. All right, so I have negative 1 and 48 hundredths. So now I need to write that as an improper fraction. So to get 1 whole, I had to have had 100 pieces. So I'm going to skip right to adding that 100 pieces to 48. So I'm going to have my negative, and then I have my 148 over 100. And I can divide both these numbers are divisible by, not 5. Since that's an 8, they're both going to be divisible by 4. Because I know 100 divided by 4 is 25, so my denominator is going to become 25. And a negative 148 is going to give me a negative 37. And that's how we take a decimal and make it into an improper fraction, which will then show me that my decimal is a rational number, because rational numbers have to be able to be written in m/n.